Here I built a simple embedded system using a very famous microcontroller called the Arduino. The model of this Arduino is Mega 2560, the third revision, by another popular company called Elegoo. And this simple embedded system turns on three LEDs one by one. And let's quickly look at the code. Here is the code of the system, the software system, and is one of few cases for using infinite loop. When we cover a while loop, we talk about infinite loop. When we write simple applications, computer applications, we should avoid creating an infinite loop, at least most of the time. But here is a case we need to use infinite loop, which is making some applications for embedded system. So from here, we create three integer type variables. They are LED 0, 1, 2, corresponding to pin number 3, 11, and then 13 on the board. And they are here. So for pin number 3, there you go. This is pin 3 attached to this blue LED. And then pin 11 and pin 13 attached to the other two LEDs, yellow and red. For Arduino, pin 13 also connected to a internal LED here. They is hardwired. So here we have two functions. The first function is called setup. It's a built-in function, same as loop. That's a built-in function, which means the name cannot be changed over here. This is not customized function names or functions. These are built-in functions. Okay, so pin mode, we turn all the LEDs to be output mode, which means providing the voltage to those three LEDs. And here is that infinite loop, just called loop. Inside the loop, inside the infinite loop, there are code. Turn on the first LED, turn off other LEDs, and then put a 1 second delay. Now we turn on the second LED while other LEDs are off, and then add a delay. And now we turn on the last LED, and then other LEDs are off. Put a delay, and then the loops go back to the beginning, and then runs the same code over and over again. Now we can see the lights turn on one by one. It's very easy. However, this program shows a case that we need to use infinite loop. So the loop here actually is a while loop. That loop is a while loop, and it is while 1, which is same as the loop here. Inside the while 1 is that code that need to be run over and over again. The system will run this code over and over again until a person, the user, the operator, disconnect the board from the power source to shut down the board. Besides Arduino, there are other popular boards available in the market, such as one is called a BeagleBone Black, a BeagleBone board. The Black is just one version of it, one model. So this board is good for making some simple embedded system like this, or even IoT, Internet of Things devices. And the other one is called BeagleBone AI. This kind of board supports any embedded system with AI, artificial intelligence feature enabled. There are other branch or other model of BeagleBone boards, such as BeagleBone Blue. If it's BeagleBone Blue, that board is good for robotic things. And besides BeagleBone boards, oh, by the way, they are made by TI, Texas Instrument. And besides these two boards, there is another one. Here is high-end used in the industry. It's still by TI and Texas Instruments. this is the Tiva C series, not a Big Bone series, a different series. Also great for embedded system with additional features. And here has another board, also pretty popular by a different company called Cypress. This is PSOC 6 BLE, that's the Bluetooth features supported. And besides this board, there are plenty other microcontrollers, such as STM32, MSP 64 boards. And you may ask, what's the point? Why we need to have this board? What can they do? What are the applications? Such as we can put the board inside the drone here. And then the pins, either this side, the digital pins, or the other side, the analog pins, can control some components over here, such as the brushless motors, some speed controllers. You can also put some sensors here, infrared sensor, LiDAR sensor, ultrasonic sensor, and so on. And you may also need the board to control such as this device. It's a joystick. You can make it pivot into different position to control the directions of a robot or of the drone. And over here, I have some chassis or the rovers. As you can see, there are some motors. Those are the brushed motors, which can generate more torque and make this run faster. And besides that, here I have a Arduino kit. Now I have multiple kits. Inside, these are the sensors or peripheral devices. So here has another DC DC motor, and then this is a ultrasonic sensor. So send a sound wave, sound burst. The sound burst hit the obstacle and then come back. And the microcontroller can compute the time, so measure the distance. So that's the demo about. It shows the applications of using infinite loop.